Okay, so on this page, this is the last page of day 6. On that extra page I gave you to replace. Payday Loan Company makes loans between 100 and 1,000 available to customers. Every 14 days, customers are charged 30% interest with compounding. In 2013, Remy took out a $300 payday loan, which expression can be used to calculate the amount she would owe in dollars after 1 year if she did not make payments. So this one is a little trickier. If we were just writing a basic formula, let's say we were getting that interest every day, we would do 1 plus 0.30, so 1.30 to the time. So first off, I'm going to cross out these two because they have 0.30, which is not correct. Now, we don't want to get our interest every day. We want it to take 14 days to do it. So this is going to be t over 14, kind of like we have in a half-life formula when something takes longer than the time period to happen. Now, we want to see how much we're going to have after 1 year, okay? So the number of days in 1 year, so t is going to be 365. Another way, if you at least got it cut down to these two answers, you could think about it, is if you think about it, if it happens every 14 days and we're going a whole year, we expect it to happen a bunch, right? So this number is going to come out to definitely bigger than 1. This would be just a fraction of a time. So 4 makes the most sense. A savings account S has an initial value of $50. The account grows at a 2% interest rate compounded n times per year according to the function below. Which statement about the account is correct? So we're starting with 50. We don't know how many compounds there are. Okay, so we could plug in any sort of number. This is a pattern question. So as the value of n increases, the amount of interest per year decreases. Now, what I would suggest is trying different numbers for n and looking on your calculator to see what happens in the y equals, or just plugging in a number for the time. But the more we compound, we know the more we get, right? So that one is not true. As the value of n increases, the value of the account approaches the function s of t equals 50 e to the 0.02t. Now that one's true because as n increases, we're heading towards infinity, right? So we know that the compounding formula heads towards the PERT formula because the PERT formula is compounded continuously or an infinite number of times. So let's say you didn't know that. We'll look at the other ones and think about why they're wrong. As the value of n decreases, the amount of interest per year increases. So this is really saying almost the same thing as number 1. Okay, so now we just switch the increases and decreases, and that wasn't true on 1, so it's still not true on 3. As the value of n decreases to 1, the value of the account approaches the function 50 times 1 minus 0.02 to the t. As it heads towards 1, it would approach the basic formula, but that would need to be a plus. So 2 is the correct answer. Number 11, in New York State, the minimum wage has grown exponentially. In 1996, the minimum wage was $1.25 an hour, and in 2015, it was $8.75. Algebraically determine the rate of growth to the nearest percent. So we're going to need to set up some sort of equation. We have no special stuff. We know it's exponential, so I'm just going to use my basic formula. We're looking for R, the rate of growth, as a percent. We'll plug in things we know. So the start value at the beginning of time, or we're going to say time equals 0, we're going to set that to 1966. 2015, if I subtract the 2 years, I get that that's 49 years, okay? So we're starting with 125, we're ending, so we're gonna plug that in for A of t, with 875. Our time is 49 years, and we're gonna look for something related to the R. So at the end, we have 875, we're starting with 125, 1 plus R to the 49th. So the first thing we're going to do is divide. And that's going to give me 7 equals 1 plus R to the 49th. Now this is technically in Venn form, but I'm not trying to solve for t, I'm trying to solve for R. So we're going to use the reciprocal exponent, so 1 over 49, to cancel here, and we'll raise 7 to the 1 over 49. If I type that in, I get 1.0405 approximately equals 1 plus r. So we'll subtract 1, which means the r is 0.0405, which means the percent that came from that to the nearest percent is 4%. The last one, the half-life of a radioactive substance is 15 years. Write an equation that can be used to determine the amount S of T of 200 grams of this substance that remains after T years. So I'm not even doing the next part. I'm just going to write the function first and make sure I get credit for that. We're starting with 200. We have half-life, so my base is 1/2 to the T over H. So the half-life is 15, so there is my function. That's part A. And it does help sometimes if you label them to make sure you're hitting up multiple parts of, all parts of a multi-part question. Now we are going to determine algebraically to the nearest year how long it will take for 1/10 of this substance to remain. So it doesn't want 1/10 of a gram, it wants 1/10 of the original. So I'm going to take 1/10 of 200, we want 1/10 of the original, which equals 20. So I'm setting it equal to 20, I'm not going to set it equal to 1/10. That gives me 20 equals 200 times 1/2 to the T over 15. And then we're going to divide by 200. Now, not surprisingly, this gives me 1/10 or 0.1, right? Because we knew that's how much we wanted to have left. So now I am in a situation where I have base to the exponent equals the number. I'm trying to get to the exponent. The T is in the exponent, so I am going to put it in log form. So this is base 1/2. The number it's equal to is 0.1, and it equals the exponent. If I take this in, this expression here, that is going to give me about 3.32 equals T over 15, and then I'm going to multiply by 15. And so I get that T is 49.8 to the nearest year we want, so that's going to be 50 years.